Welcome to Statics Lectures by Civil Thinking, and today we are going to see another concept, that is how to find zero force members in trusses. Now before I move on, I suggest to you to please watch the video lecture on truss analysis one by one in sequence so that you understand better. The link is in the description, or also you can click on the pop-up on your screen. Now coming to today's class. In this class we will see zero force members. Okay, we will basically talk about tricks. Okay, what are those tricks and how how did we find those tricks, and we will also solve some example problems based on those tricks. Okay, now let's first of all talk about zero force members. Okay, in short I will write them as ZFM. Okay, zero force members. Now what is the introduction? Now, a zero force member is a member in a structure that supports no loading. Okay, now this is important. Now what is a zero force member? Which have, in a truss we have members, right? And these members carry force, right? They can carry force which can be either tensile forces or compression forces. Okay, whatever the case may be, but always these members carry the forces. Okay, if for example there is some member, for example this member, okay, and this member have zero force in it. Okay, that is, it does not carry any axial force, then we call it as zero force member. Okay, now a member may be necessarily only for the stability of the structure during construction and for the applied load, and if the applied load is changed. Okay, now zero force member, sometimes it happens in a structure when we design, when we do a bad design. Okay, we don't do the proper analysis, we construct a truss and there is some extra member which is not important. Okay, because it is not important to carry the load, so it will not carry load. Okay, that could be the reason, one reason why there can be a zero force member. What is the first reason? First reason can be lack of design, right? Because we did not care much in the design, so there are some members which happen to be zero force members, okay, which we didn't need. Now second reason why we have zero force member is deliberately. Okay, we keep zero force members deliberately. Now here is the reason why. The member may be zero force member for the stability, read here, stability of the structure during construction and if the applied load is changing. Okay, these two reasons are other. Now this one is not deliberate, right? It is accident, right? It happens accidentally. Okay, now number 2 and number 3 which I will talk, okay, these are deliberate. Deliberate, I mean to say, we keep these zero force members in the truss. Okay, why? Now what is the second reason? The first reason why we keep it deliberate is because the shattering, you might have heard about the shattering, during when we construct something. Okay, during construction, right? First of all we use this shattering, right? Okay, for example there is a slab. Okay, you want slab. Okay, concrete slab, for example a concrete slab. Okay, now when you want to lay down a concrete slab, but before that what you have to do? You have to do what? You have to construct a what? The framing structure to carry the fresh concrete, right? We call it as shuttering. Okay, similarly in these trusses sometimes we keep extras. For example you have, you know you have a slab here, so you will keep some extra member here. Okay, now this is a zero force member, but you keep this to support the shattering. Okay, so zero force members may be important during construction, right? During construction, for example to support green concrete, or we call it as fresh concrete, right? Now what can be the another reason we deliberately keep is when the applied load is changed. Now let me tell you this concept. you know Let me talk about this. We keep a zero force member, okay, to keep us safe in case the applied load changes. Okay, applied load changes. Okay, to keep safe in case the applied load changes. Now what I mean to say, now for example, now concentrate here on this truss, focus on this truss. For example, we have a load here. Okay, now we know how to find force in these members. How do we find forces? We find forces using two methods. What? They are method of joints, right? And second is method of sections. What is it? With the help of these two methods, we find what? We find forces, right? Forces in members. Okay, with the help of method of joints and method of sections, we find forces in members. Now I have already made a video lecture on method of joints and method of sections. If you want, you can watch that. Okay, I will also provide the link in the description. Now with the help of these, we can find the forces if they exist. Okay, for example, we have a load W here, right? Now because of W, there will be some forces in some members, and for example, there will be some member which don't have force. Okay, now we denote a zero force member with an O on it. Okay, like this O means this is a zero force member. Okay, now let us say, now this W, for example, this was a car. Okay, a vehicle, and this is a bridge. This is a bridge, and we have a car on the bridge. Okay, this W, it is basically a car. Okay, this is a car, and this is, we have a bridge. Okay, we have this bridge. Forget about the drawing, just try to understand. We have one, there is a moving car, okay, which is moving in this direction towards right, and first it exerts load here, and because of load 1, this member is zero force member. Okay, this member becomes zero force member. Now why this becomes zero force member? Because the load is at this joint. Okay, now let's say, now the load is not here. Okay, let me move it. Now let us say, in the second case is what? Now the car is moving, okay, like this, and now the force is here. Okay, the force is here. Okay, this is the second interval. Okay, the second case. Now because of the second case, tell me, will there be a zero force here? No. Okay, now this is not a zero force member, right? Now initially was what? The first case was what? First case, the car was here and this member was a zero force member. Okay, so for, I'm just telling an example. Okay, so since it is a zero force member, we don't need it. Okay, so what we have done, we could have removed this member. Okay, but no, we will not remove this. Even if it is zero force member, we will not remove this. Why? Because we know the condition will change. Okay, the zero force member will not be a zero force member anymore. Okay, now what we did, we move the car here. This is the second position, and now this is not a zero force member. Now imagine if we had removed this member. Okay, if we had removed this member. Okay, now when the car was at this point 2, joint 2, okay, the load was here. Because there was no support here, I'm consider the case if we had removed this member. Okay, then this bridge, this truss would have collapsed. Okay, so we know the condition, because we know, that's why we have these things written here. Applied load is changed. Okay, then the zero force member becomes unnecessary, right? So zero force becomes necessary, we keep it deliberately. When? During construction. Third, when we know the applied load is changing. Okay, now there might be other reasons too why we keep zero force member. Okay, or there may not be. Now I have a question for you. Do you know any reason why there should be a zero force member? If you know, please comment. Okay, so we have already talked about this point 2. Now let's talk about this point 3. Now a zero force member is either removed from the diagram, and if not removed, then it is shown by writing O 0 on it. Okay, I have already told you we don't need a zero force member. Okay, you know, we don't need a zero force member unless these two conditions are there. Okay, if these two conditions are not there, if we don't need zero force member, so what we do, we just remove it, right? We remove that member, right? We remove that member. Okay, now let me draw here. Okay, let me draw two members here. Okay, now let us say this member is zero force member. Okay, we either denote a zero force member with by writing an O or 0 on it, okay, on the diagram, or we simply remove that member. Okay, anyways, we complete this point. Now what we have another point here. We have this point here. We can find the zero force member using method of joints and method of section, but when we use some tricks which we will see in this class, will save our time. Now method of joints and method of sections, what is the use of them? We find forces. Okay, if there are forces, we find them, and we also find zero force member. Okay, because when we apply method of joints and we found the force in a member is 0. Okay, if it is 0, it means it is a zero force member. So since we can already find which member is zero force member and which member is not zero force member with the help of method of joints and method of sections, right? We can already find zero force members using these two methods. So the question is, why we need some tricks? Why, if we can find method of zero force members with the help of these two methods, okay, then why do we need tricks? The reason is, will save our time. Okay, this is important, because of course we can apply these methods, but in some exams we don't have much time. So in order to save the time, we apply some tricks. Okay, because they are very fast. Okay, so they will save our time and we can solve maximum problems in our exam. Okay, right, exams like FE exam, fundamentals of engineering exam by NCES, or any other university exam, right? So we can save our time, because in some exams like we have FE exam by NCES USA, that exam, for example, the time is very important, the time is limited. Okay, we had to solve maximum problems, so this is the reason we need to apply some tricks there. Okay, now we have talked about the introductory part. Okay, now let us go deep dive into the tricks. Okay, let us see the tricks. Okay, now, okay, here are the tricks. Now how many tricks we have? We have four tricks. Okay, we have four tricks to what? In identifying zero force members. Okay, I denote them with ZFM. Okay, zero force members. Okay, now what are these four tricks? Okay, this is written here. This is trick 1, trick 2, trick 3, and trick 4. Right, this is trick 1, this is trick 2, this is trick 3, and this is trick 4. Okay, now let's talk one by one about these tricks. Okay, now these are the joints. Okay, these are the joints of the truss. Okay, don't worry, we will understand everything when we move on in this class. Okay, now I have just drawn the joints of a truss with their connected members. Okay, connected members, here we have two members connected at this joint, and at this joint we have three members, right? This blue, black, and green, these are three, 1, 2, and 3. And here we have also three members connected to this joint. Okay, because four tricks, they apply to the, we have to see the joints. Okay, we see the joints and connected members. Okay, and connected members. Okay, now Let us go into trick one. Now trick one is, now I will not read everything, okay, this text, it is for your reference, okay. If you wish, you can read everything, or you can just listen to me, because I know what it is written, okay, because I already know the concept, okay. Now the trick one is, what is the trick one? Trick number one is, if we have one joint, what if we have one joint without any supports can be pin joint, a roller, right, but we have this joint without any support, or we don't have any force here, right, without any let me write, no force on joint and no external support, okay. This joint have no force and no support, and we have two members connected here, okay. Now when this condition is somewhere in the truss, when you see something like this, it means both the members are zero force members, okay. Okay, now trick number two is here. Trick number two, if we have one joint without any support, okay, no force, no, okay, so we also have this condition here, no force, no external support, okay. Here we also have these two conditions, okay. And what we have, but here we have three members, right, three members, right, but you can see this black and green, they are collinear, okay, because if you draw an imaginary line here, they both lie on the same line, right, so these two members are collinear, right, and one member, which is this blue member, this is not a collinear member, okay. So two are, let me write here, we have three members here, right, three members here, from here, from three members, two are collinear, right, collinear, and then this other non-collinear member is a zero force member, okay, okay. So this non-collinear is zero force member, okay. Now these are the conditions, no force, no external support, okay. So now let's talk about trick number three here. Let us talk about trick three. Let us talk about this trick, okay. Trick number what? Trick number three, yes. Trick number three. Now trick number three is, again, we have three members, right, and two are collinear and other is 90 degrees, okay, or we only have two members, okay. Here we have two members, okay, at this joint, right, and we have one force, okay, this load or support, okay, we have this load or support present, but it is making an angle of 90 degree, okay, with them, okay, okay. Now if we already know this is a zero force member, okay, it means this is also a zero force member, okay. I hope you understand this. Let me show it here again. We have two members and the force or support is shown with this arrow, okay. This arrow can be a support or it can be you know an external force, okay. Now we already know this is zero force member, okay, we already know. Now since this is a zero force member and they are collinear, it means this is also a zero force member, okay. Here we have force at 90 degrees, right, okay. We have two forces collinear, all right. One is zero force member, it means the other member, the second member, is also zero force member, okay. Now let's talk about this trick. Let's talk about trick 4. Trick 4. Now this talk says about trick 4. Okay, now we have two members. As you can see, two members, the black and the green, two members. Okay, and we have some external force or support, okay, along the axis of one member. Okay, because this force is along the black, right? It is along the black member. It means the other member perpendicular to this force is zero force member. Okay, for example, let me show it like this. What if we had like this was joint. Now if we have force like this, then this would have been a zero force member. Okay, now let me show it here. Now let's say the force is here, the force is along this member. Okay, and they are making an angle of 90 degrees. Okay, they are normal to each other. The force is along this member, it means this one is a zero force member. Okay, so these are the four tricks. Now some educators, some teachers classify them only into two rules, okay, or two tricks. Okay, but I personally I like to classify them into four tricks. Okay, so if you watch another lecture from some another tutor and it only says there is only two rules, two tricks or three, don't worry about that. Okay, you can perfectly understand everything and there is not much difference. Okay, actually I have added more rules, okay, to make things more better. Okay, now okay, so now until now we only talk about tricks, okay, but I did not told you where did they come from. Okay, how, where did they come from? Okay, tell me where did they come from. Okay, because we did not talk about that. I've just told you these four tricks, right? Now let us see where did they come from. Okay, now here is the proof of these four tricks. Okay, now what was the trick one? Trick one was we have one support, it does not have any external load or any the support, right? Then both the members are zero force members. Okay, now let us see how. Now we will apply method of joints. Okay, we will, with the help of method of joints, we will prove our tricks. Okay, now let us see two members in this truss. As you can see, we have this truss. Okay, we will whenever we try to apply these tricks, we see the similar pattern. Okay, where at which joint we have this similar pattern. Okay, similar condition. Now if you see carefully, at joint A we have something similar to our trick, right? Joint A is without support or load as it is here in the trick one, right? And it have two members as in this trick one. Okay, so trick one, joint A is similar to the conditions of trick one, right? So both of these members are zero force members according to the trick one, but first we will prove how. Okay, now let's apply method of joints. Okay, now let me draw it here. Okay, let us say this is x-axis, let us say this is y-axis. Okay, now we have, this is joint A. Let me erase these things. This is joint A and we have two members here, right? This is one member and this is another member, right? Now this is AD member, so I will call this as force in AD. I hope you know these things. If you don't know these things, please first watch the method of joints. Okay, first watch the method of joints. Okay, I have already made this video lecture on it. Okay, now let's assume the angle between them is theta. Okay, now this member is what? This is AB member, so this arrow is force in AD. Okay, now let's apply the equations of equilibrium. First of all, let us resolve this FAD because this is not along x-axis or y-axis, so this is FAD cosine of theta, and here we have FAD sine function of theta. I hope you know these things. This is the resolution of forces. You will understand everything. If you have not watch the method of joints, please watch the method of joints. Okay, you will understand everything. Now remember, the link to watch the method of joints is in the description. Okay, or you can also click on the pop-up on your screen. Okay, so let's apply these equations. Summation of f of x is, no, let us apply this. Summation of f of y is 0. So sum up all the forces along y-axis. We have only one force along y-axis, so it is FAD sine theta. FAD sine theta, it is 0. Okay, now when you rearrange this, we get FAD is 0, right? Now FAD is 0 means what? Force in AD member, this member, it is 0, right? Because it is 0, it means this is a 0 force member. Okay, so this becomes 0, right? Now let's apply summation of forces along x-axis to be 0, because these are the two equations of equilibrium we use in the method of joints. Okay, now along x-axis we will use FAD plus FAD cos theta is equal to 0. Why? Because we have to sum up all the forces along x-axis. How many forces we have along x-axis? We have this FAD and FAD cos theta. I summed them up and equated them to 0. Now FAD is already 0, right? This is 0, so I will erase it. So FAD cosine of theta is 0. So from here we get FAD to be 0. Okay, so sorry, this is not FAD, this is FAB, right? FAB. So we get FAB is this number. So the force here is 0. Okay, so this means FAB is also a 0 force member. Okay, so this way you can see our trick 1 is proved, right? Because this joint A was without any external load or force or support, and we had two members and both of them are 0, as the trick 1 says. Okay, so whenever we see this pattern, we will not apply these equations, right? Because why do we learn these tricks? To save our time. If we apply these tricks, these equations, they will consume our lot of time and energy. So we will just simply apply the trick when we see this pattern. Okay, when we recognize this pattern in at any joint of a truss, okay, then we will very fast will mark both the members as 0 force members. Okay, without applying these equations and wasting our time. Okay, now what is the trick number 2 is if we have three members, both of them are two are linear, right? This black and the blue are is linear. There is no load, external load or support here, right? Then the third non-collinear member is a 0 force member. Okay, now let us observe this pattern in this body. Okay, let me erase this first. Okay, so now can you see this pattern at any joint? Let me also erase these things. Okay, now if you look at joint B, for example, until now you don't know this is a 0 force member. This is just for example. Okay, now suppose you don't know this trick 1, you don't know, so you know this member B, joint B. Okay, let me draw the axis first. This is x-axis, and let's say this is y-axis. Okay, y-axis. Now this BA, this is force in AB member, this is AB member. Then we have here, let me change the color. Then we have this BC member, right? Force in BC member. Okay, then we have this BD member, which is not perfectly 90 degrees, right? So it is inclined at some angle. Okay, let us say this is force in BD. This is our joint B, right? So you can see joint B is somehow similar to trick 2, right? You can see trick 2, three members, joint have no support or load. Okay, two members are collinear. Okay, these two members are collinear, BC and BA, they are collinear, right? So which is a non-collinear member? This BD is a non-collinear member. So this becomes a zero force member, okay, as according to the trick number 2, and we have to prove that this is a zero force member, right? We have to prove this. Okay, now let's first resolve this FBD. Let us say this is, assume this angle is theta, so this is FBD cosine of theta, and this is FBD sine function of theta, right? This is the resolution of FBD. Now let's apply these equations. Summation of forces along y-axis is 0, and then we will apply summation of forces along x-axis is 0. Okay, now let's apply this. FBD sine theta is 0, right? Because we have to sum up all the forces along y-axis, right? So along y-axis is this axis, this is the y-axis. We have only one force, which is FBD sine theta, right? Now, okay, so from here we will get FBD to be 0, right, from this equation. So force in BD is 0. What is BD? BD is this member, BD. Okay, it is a zero force member. Okay, so force in BD is 0, so this becomes a zero force member. Okay, now we don't have to apply summation of f of x. Why? Because we already proved our trick 2. Okay, so we have already proved the trick 2, that if we have three members at a joint which does not have any support or an external load, two are collinear, then the other non-collinear member is a zero force member. Okay, so whenever we see this pattern, any wire at any joint of a truss, we will apply very fast and we will conclude this non-collinear member is zero force member. Okay, and it will save our lot of time. Now let's move on to trick 3 and 4. Here we have, now what was the trick 3? Trick 3 was, if we have two members and we have one force here, okay, or some support reaction, this is support reaction or an external load, whatever, and we already know, okay, this is zero force member. Okay, what we know it already. Okay, this member is already a zero force member, then these are collinear, then this is also a zero force member. Okay, then now let us prove it. Let us first see any condition similar to trick 2. Now you can see joint A, it is without supports or any external load, and these two members are both 0, right? Because this is according to the trick 1, right? Remember, according to trick 1, you see how fast we found. Now let us see this, condition. How can we find this condition? Now look at joint B. When you apply this W, there will be some reaction here. Okay, there will be only one reaction at B and there will be two reactions at C. Okay, now we don't have to care about this reaction, but we have to care about this B reaction. Let me draw it here. Let us say this is x-axis, this is y-axis. Okay, now we have one load here, right? The support reaction, as you can see here, I write this here. Now this is already a zero force member. Okay, this is a zero force member. Okay, so we will not show it here. Then we have force in BC here. This is BC member, this is B. Let's say this arrow shows the force in BC member. Okay, this is BC. Okay, so I show the force of this BC with the help of this arrow. Okay, now let's apply this equation. Summation of force along x-axis is 0. Okay, we have this, let us say this is W, the upward, the support reaction. Now summation of f of x is 0. We have to sum up all the forces along x-axis, is this axis. We have only one force along x-axis, which is FBC. Okay, and we have to equate it to 0. So FBC is already 0. Okay, this force in BC is 0, right? This force in BC is 0. Since it is 0, it means this is a zero force member also. Okay, remember we already know this was zero force member, and these two are AB and BC, they are collinear, and so this becomes 0 2, right? So this becomes a zero force member 2. Okay, knowing we have this support reaction here. Okay, so this is how we prove the trick 3. Okay, now let us prove our trick 4. This is our trick 4. Here the two members were like L, right? Capital L. Okay, We had one member. For example, we had the force like this along one member, then the other member was zero force member. Okay, now let us see this pattern here. You can see joint D. You can see the trick 4 pattern is already, it can be found in joint D, right? Because let me draw the joint D here. Let me draw the axis first. Let us say this is x axis. Let me draw it a bit better. Let us say this is x axis, and let us say this is y axis. Okay, now joint D. Okay, we have this CD member. Okay, let me denote the CD member with force in CD member with this arrow. Okay, force in CD. Then we have force in ED here, right? DE here. So let me denote the force in DE to be like this, FDE. Okay, then we have this W here. Okay, now let us apply these equations of equilibrium. Okay, let us first apply summation of f of x. So from here FDE is 0, right? Because we sum of all the forces along x-axis, so it is 0. Okay, so we already found force in DE is 0. So we already prove our trick. Okay, trick 4 was the force was along DC. Okay, so DE member was a zero force member, right? Now let us also prove that CD is not a zero force member, because here when you have force along this member, so it is not a zero force member, but actually the other member which is normal to this force is zero force. Okay, so let us prove this is not a zero force member. Okay, so let us see it here. Now let us apply summation of force along y-axis is 0. Okay, at this joint we will sum up all the forces along y-axis. We have y-axis here, and we have how many forces we have along y-axis? FCD and W, right? So FCD plus W is 0. So FCD is, from this, FCD is negative W. Okay, so negative W is some non-zero value. Okay, so it is not equal to 0. So we proved this was a zero force member, and we also proved this is not a zero force member. Okay, this is not a zero force member. Okay, so we proved the trick 4 perfectly. Okay, so now let us see the actual steps, how to solve the problem, then we will solve an example problem. Okay, now let us see this steps very fast. Now the first step is, we have to draw free body diagram of whole truss, and roughly find support reaction. Okay, now you can already read it here. I already written this. The step 1 is this. Now you have to draw the free body diagram. Draw the free body diagram of the whole truss. Okay, of whole truss, and roughly find support reaction. Now why I write this roughly? Because you don't need to find the exact value of support reactions. Okay, you just need a rough idea. So this was the step 1. Because why we need roughly? Because when we find the rough support reaction, that will tell us a joint if there is a support reaction or not, right? So let's come to the point 2. Point 2 is this. Then observe each joint of truss to, then what you have to do, the step 2 is what? The step 2 is you have to identify if any trick in truss. Okay, you have to identify any condition, you have to identify if any support, if any support is similar to what we is similar, right? Similar to what? To any of 4 tricks. Okay, then we apply that trick accordingly. Okay, so these are the only 2 steps. Okay, first is find support reactions, but roughly, because it will save our time. Okay, save our time roughly. Now then step 2, we have to identify if the any of the 4 tricks are present in the truss, That's it. Okay, now let me actually solve some simple problem here. Okay, now this is our truss. In this truss we have to find the number of zero force members. Okay, we have to see how many zero force members are here. Okay, now for your reference I have already shown these tricks. Okay, trick 1 is this, trick 2 is this, trick 3 is this, and trick 4 is this. Okay, now for your reference I show them here. Okay, so let us be very fast. Now joint D is similar to trick 1 because joint D have no load or no support, so these two are zero force member. Okay, now until now we have how many zero force members? 2. Okay, now look at joint C. Now because this is a zero force member, okay, and we have one force here normally, okay, so this is also a zero force member. Okay, we have another force. Okay, because here at joint C we have this trick 3, right? Because you know what was the trick 3? If two members are collinear and we have another force here, okay, W, doesn't matter if there was a member here or not. Okay, it could have been a 3 members too. I told you there are, let me tell you here, I told you what, there are 2 members. Okay, but actually there could also be 3 members. Okay, that's not the case. There could also be 3 members, but this member is acting at 90 degrees. Okay, and the force is along it. Okay, so we have 2 plus 1 tricks here, right? 2 were because of joint D, and this one is why, because joint C. Okay, now look at joint A. Okay, now joint A is similar to trick 1 again. Okay, we have 2 members. Okay, at A there is no support at A or external load. Okay, so both of them are zero force members. Okay, so we have another 2 zero force member. Okay, now look at joint E. Okay, we have these 2 members, they are collinear. Okay, and this member, okay, is non-collinear. Okay, at E there is no support, there is no external load at E, right? At E, so you can see this is similar to what, similar to trick 2, right? Look at this trick 2, look at this joint, there is no support here, no load here. At joint E there is no support or load. Okay, two members are collinear, one is non-collinear, so the non-collinear is a zero force member. Okay, so these two are linear, collinear, so this non-collinear is zero force member. Okay, so we added up one more. Okay, so look at another joints. Okay, joint H, joint F. Joint H does not have any, pattern like those of four tricks. Joint F also does not have any pattern. So overall we have 2 plus 1 plus 2 plus 1. Okay, 2 plus 1 is 3, 4, 5, and 6. Okay, we have total 6 zero force members. Okay, now let us modify this. For example, let us say there were some support reactions. Okay, because I have not considered the support reactions. Let us say there was some support reaction like this. Okay, okay, so we have this W here. Now because of this W we will have reaction here. Okay, and also reaction at D. Okay, so this is the first step. Step is find the support reaction roughly. For example, I will say, let us say this is 2W divided by 3 and this is W by 3. Okay, this is roughly, I'm not saying this is perfect, the actual. Okay, I just know we have this reaction, load downward, so because of these there will be upward support reaction. Okay, now because of this, now look at joint A. Okay, let me just draw the reactions. Okay, because remember, we just need to know the loads. Okay, now this joint A is similar to what, similar to trick 4, right? We have load along this, so this is a zero force member, right? So we have one zero force member. Okay, now what, look at joint E is again the same like trick number 2. Two members are linear, there is no support at E, and there's also no external load or force at E. Okay, so this is a zero force member. Okay, so we have one more zero force member. Okay, now plus, do we have another zero force member? Let us look at this joint F. There is no pattern at joint F. Now let us look at this joint C. Now this is no more a zero force member. Okay. Okay. Now as I can see, there are, we cannot find any zero force member. Okay. So there are two zero force members. Okay. Let me know in the comments if I am correct or I have done any mistake. Okay. So this is how we find zero force members, and in the coming class we will solve another problem on how to find the number of zero force members in the trusses, okay, using our tricks. Okay, so and I think that's it for today. If you have any doubt or any suggestion, please comment, and see you in the next class. Thank you.